Welcome to Digital Toolbox. In this tutorial we're going to go over attractor points in Grasshopper, a really basic definition where we can set up an array of circles and then the circle's size is controlled by the distance away from this point, which we toggle in Rhino. So it's a pretty small definition. I'll go ahead and just delete these buttons and walk you through it. So here's the only thing that we have in Rhino is one point. I've taken that point and I've set it up to this point button, and I'll set that one point. It's already set. So now I'll make a grid. So the grid is under vector point, and we'll do rectangular grid. You can do hexagonal grid as well, and it'll ask us for a few things. The first is the base plane. That's going to be at the origin to begin with, and then we'll put in how many we want in the number of steps along the x and then the y. I have some toggles there to begin with, and the last is going to be the distance between the points. I'm just going to use this same slider for both the x and the y, and that'll give us a square, and then I'll use another slider for the distance between each of them. We can get a point geometry and drag that down here, and then you can see just the points, and then we can go ahead and unpreview the rectangular grid, so now just the points are you can see them. So now we're going to create circles based on all these points. These circles are just under curve, primitive, circle, and then it asks for p, the points, so we can apply these that circle to the points on the grid, and then the radius, it wants us to define a radius. So I'll just copy this slider, and this will be our radius. 4, here's 2, and then 1. This radius we can toggle with a slider just like this, but we can, for the attractor points, the radius of the individual circles will be controlled by the distance they are from the point that I've already set. So I'll just delete this slider, and I'll grab the distance button, which should be under vector point distance. So as for the distance between A and B, we'll say that B is the point that we've already set, and then A is going to be the points on the grid, and then that distance will be our radius. Now you see that distance for the radius is a little not quite proportional, the proportion that we want. So we can downsize this. I'll just grab an F1 one variable function, and then for that function I'll just downsize it by going something like x over 12. This will be, it might maybe different if you choose different variables or different sizes. So we'll take that distance, run it through the function, and here you can see it's gone through it's downsized it, so now it's much more believable. So that's pretty much it. The distance of the attractor point controls the radius of these circles. If we want to further expand this and give these circles a maximum and max out the size of them so they don't cross over, we can throw in a minimum button. So I'll just type in minimum right here. Minimum pops up, and it'll give you the minimum or the lower number between A and the B. So we'll just take the since these are on a grid that has the step size of 4, we'll want half of that to be the radius, so they don't overlap. So I'll just copy the F1 function, and then here we'll put in x over 2. So that way it'll reduce our step size. We'll throw this into the original step size, and then that'll reduce it down to 2. So that'll go into A, and then B can be the same point or the same point, and then we'll throw that into R, and then that way the circles just take the smallest radius and are maxed out at the grid size. So there you have it, and enjoy.